Before we start work on scientific notation, I want you to look at this. There are three parts to a number written in scientific notation. There's this first part called the coefficient. It is always going to be a decimal between the numbers of 1 and 10. There will be one digit right here, and there may or may not be anything afterward, but there will always be one digit before the decimal. It will be a base 10 number, and it will have an exponent. The next thing I want to tell you before we start is that you are very fortunate to get to be here to witness us having our roof worked on. So if you hear banging around, it's a roofer on top of our house. That's kind of cool. And here you are listening and participating in it. You have this page. I'm going to tell you what to write. I want you to take time to write these notes because going through that process will help you better absorb the content and how scientific notation works. You have two types of numbers. You've got regular notation, which is the normal way, and scientific notation. What you will write here, regular notation, is the standard way that we write our numbers. For example, 280 million is written 280 million. So that's the standard way of writing it. Scientific notation, however, is a shorthand or like a shortcut way of writing really large or really small numbers in scientific notation. In scientific notation, a number is written as the product because you multiply, see? The product of two factors. There are always two factors. There's this, the coefficient, and there's this, the 10. For example, 280 million can be written in scientific notation as 2.8 times 10 to the 8th power. So that's the same number in standard or regular notation and in scientific notation. Now take a moment and look at the example number in the middle. This is the first factor. It's known as the coefficient. It is a number that is between 1 to 10. There will be one digit always right here. It may or may not be a decimal. Occasionally it won't be a decimal. For example, if we had 3,000 in scientific notation, since there's not any other non-zero digit, it would be 3 times 10 to the third. So there's not a need for a decimal. The second factor is always a power of 10. The power of the exponents tells you how many places to move the decimal point. The sign of the exponent tells you which direction to move it. If it's a positive exponent, you move the decimal to the right. If it's a negative exponent, you move it to the left. And that's what this tells you. If decimal is moved left, exponent will be positive. If decimal is moved to the right, exponent will be negative. So we are changing from regular notation to scientific notation. To change this into scientific notation, we will move the decimal after the 4 and before the 2. So it's going to move here. And let me take a highlighter and remind you that it will be 1 digit before the decimal when we put it in scientific notation. It will always be the first non-zero digit. So to get it right after the 4, we move the decimal 4 places. So in scientific notation, it would be written 4.2 times 10. And you see 1, 2, 3, 4, 5 to the 5th power. You know what you can do? You can go down and write times 10 on all of these. You will move the decimal all the way over here after the 7. So you write 7.35. The rest are zeros. You don't write them here. You count that in the exponent. There are 8 digits after this decimal. To move this number, now this one's a little bit different. We will write it as 8.97. Now this time though, to convert it to scientific notation, we move it 1, 2, 3 places to the right. Next, look at this really tiny number. You will write 1.4 and the decimal moves 1, 2, 3, 4, 5, 6 places. So this will be a -6. And it's easy to know if it's a positive or negative exponent. If the number is smaller than 1, it's negative. If the number is bigger than 1, it's positive. It's really very simple. Now make sure you take a moment and get all of this written down. I went ahead and highlighted in pink every number that's going to go first in the coefficient. It will go before the decimal. It's always the first non-zero digit in every number. I also highlighted yellow, the ones we'll do together, and I went ahead and put my times 10 because they're all times 10. And number 9, I kind of extended the line a little bit because we're going to have to write a lot because they stick a lot of zeros in there and then put more non-zero digits after them. So we ended up having to write all those zeros. That was rude. It's easy to look at a number and know if the exponent is going to be positive or negative. Remember, if it's a big number, it's positive. If it's a tiny number, you've got this decimal here, and then it's an itty-bitty number, then you're going to have a negative exponent. So it's really simple if you think about it. Rather than just trying to memorize the rules, if you just think about what makes sense, then you won't have any issues. Let's go ahead and do the first ones. The first digit is 4, so my coefficient will be 4.5 times 10, and I move it 4 places. I've got the 3 zeros and the 1 digit, so it's 10 to the 4th. Number 4, I've got my 3.78. Now this time, because this is a tiny number, I'm going to have to move the decimal this way, from here all the way after the 3, right? So it's going to be a negative exponent. I end up moving it 1, 2, 3, 4, 5 places. So it's 10 to the -5th. This is another small number. The only non-zero digit is 5, so we don't have a decimal in it because we just have the 1 non-zero digit. We'll move the decimal 1, 2 places because it has to come after that 1 digit. So then it's going to be a -2. 7, 8, and 9, you can clearly look and see 7 is positive, 8 and 9 are both negatives. 7 will be written as 7.07. We start with the first non-zero digit and go all the way to the last non-zero digit. We've got 3, 6, 9 digits after that 7. So it's 10 to the 9th power. Number 8, well, this is going to be negative. and so is 9. I'll go ahead and put my negatives there. I've got to move the decimal all the way this direction after the 8. So it's 1, 2, 3, 4, 5, 6, 7 places. So it's 10 to the negative 7. 8.9 times 10 to the negative 7. 9. All right, get ready to write. It is 1.89, and you don't get to stop here because just because you have zeros doesn't matter because you still have more non-zero digits. So you get to write all those zeros. 0, 0, 0, 9, 7. Yeah, scientific notation is not. When I think of it, I think of not having to write all that. But, you know, there are the occasional numbers like this one. And even in science where they really use it, there are going to be numbers like that. So I move the decimal from here all the way to here after that 1. So it's just a negative 1. Now let's look at these. This time you write them from scientific to standard. So this has a negative coefficient. So when I change this, I'm going to make the number smaller. So it's going to be a tiny decimal. It will have, oh, look, I made a note for myself. A decimal and then 5 zeros. 1, 2, 3, 4, 5, 9, 4, 6. And what I'll do afterwards is count. I started here and I go 1, 2, 3, 4, 5, 6. That's 6 places. Now this number has a positive exponent, so it's going to be a big number. So it's going to be 25. We're going to move it 1, 2, 3 places. So it's 2,500. Number 3, it's got a negative exponent, so I'm going to start off with the decimal. I'll move it 1, 2 places. So I have 1, 0, 1, 6, and I'm going to check to make sure. The decimal started after the 1, and I had to move it 2 places. 1, 2, and I did. Number 6, it's got a negative exponent, so I'm going to start with the decimal. 1, 2, 3, 4, 5, 6, 7, 3. Oh, I should have made this line longer too. 2, 4, 5, 6. Let me check and make sure that's right. 1, 2, 3, 4, 5, 6, 7, 8. That's right. There's a pattern for how to figure out how many zeros when they're negative exponents, and I tend to use that. But I don't want to tell you that quite yet since you're just learning, because I don't want you to focus on the rules and the patterns. I want you to just think about what we're doing. And this is going to be a decimal. So I'm moving it back 3 places. 1, 2, 3. So I have 2 zeros. 6. These are the ones we're doing together. Notice that number 9 has a negative exponent. That's the only one you have to do that has a negative exponent. So note that number 9, you are going to have a tiny number that starts with a decimal. All the others are positive. So you'll have bigger numbers.